Hello everyone, welcome back to AWS with Advait. Today we are going to go over AI model evaluation for this lecture. So here's our agenda for today. So as a review, let's go through the model development cycle. The model development cycle involves training, tuning, and evaluating the model. Training is when the model learns from the data, but it won't always perform well on the first try. That's where iteration comes in. If the model doesn't meet our expectations, we go back to the data and its features. We may perform more feature engineering or tune the hyperparameters. These are the settings that control how the model learns. Once the model is performing better, we evaluate its performance to see that it meets the business goals set out at the beginning. If the model meets the expectations, it's time to deploy it into production. That means the model is now live and can start making predictions or inferences on new data. However, how do we evaluate the model? How do we know if the model is ready? That's where evaluation metrics come in. So evaluation metrics come in two flavors. There's classification metrics and regression metrics. So let's start with classification metrics. Classification problems involve predicting discrete labels or categories. So this would be spam or not spam, cat or dog. Basically, it will either be binary or it could be multiple things. So if you had a color detection system, that would be an example of classification where you could have red, blue, green, etc. So some common evaluation metrics involve accuracy, precision, recall, F1 score, and AUC, ROC. So let's go through all of these. So we have to first start by learning what a confusion matrix is. So a confusion matrix is used to evaluate the performance of a classification model by comparing predicted and actual labels. So there are four key components. There's the true positives, which are the correctly predicted positive outcomes, the false positives, where you incorrectly predict a positive outcome. So if you don't have a cancer, but the model says you have cancer, this would be an example of a false positive. A false negative, where if you had cancer, but the model says you don't have cancer, so the opposite of what I just said in the false positives. And true negative, so you don't have cancer, and the model says you don't have cancer. It's correct. So true, as you can see, is when the model is correct. False is where the model is wrong, and it's the positive or negative is referring to the model's prediction, not the actual result. That's a very key thing to keep in mind. Let's do a comparison of all the classification metrics. First one, accuracy. This is one most people are familiar with, and it's correct overall. So as you can see, this is the true positive plus the true negatives when the model is correct, divided by all guesses. Fairly simple. The second one is precision. Precision measures the proportion of positive predictions that are correct. So you have true positives and divided by true positives plus false positives. This is basically saying how many positives that I predict are actually going to be correct. And so this is where when you use precision when false positives are costly. This would be considered a type 1 error, where you say that something is correct when it's actually wrong. So an example is that in email spam detection, you don't want legitimate emails marked as spam. High precision minimizes rejecting correct emails. Recall measures the proportion of actual positives that are correctly identified, and you use recall when false negatives are costly. So if we go to the equation, recall is true positives divided by true positives plus false negatives. So in medical diagnostics, you want to catch as many true positives, which are actual patients with cancer, as possible, even if there are some false positives involved. Again, this is assuming that it's better to misdiagnose someone as having cancer even if they do not, than missing someone who has cancer and saying they don't have cancer. Let's continue. So these two are like blends. They blend they're mixing multiple of the previous classification metrics. The first one is F1 score, F1 score is the harmonic mean of precision and recall. And again, it balances the trade-off between precision and recall. So this is when both are important. This is the formula. And AROC evaluates the model's ability to discriminate between positive and negative classes. This is the true positive rate and the false positive rate, and it's graphed to show an ARC. It's graphed to form a curve, which taking the area represents basically like the overall accuracy recall mix. It's basically how correct the model is. If you have an AUC of 0.5, so this would be like a straight line, that would mean your model is basically randomly guessing, and an area of 1 basically means that you have perfect classification. So let's move on to regression metrics. So these are tested less frequently, but you still need to know some of them. This involves predicting continuous values rather than discrete categories. For example, predicting the housing prices or the temperature. So here's some common evaluation metrics: MSE or mean squared error, R squared, and mean absolute error. If you've taken a stats class, you might have heard some of these. So let's go through a quick overview of which one's more important, what each of them do. Mean squared error punishes large errors. So this one will basically take the average squared difference between the predicted and actual. So this would basically exemplify these errors. There is root mean squared error, which is a little more, it's like a toned down version of mean squared error. R squared is useful for understanding how well your model fits the data. And mean absolute error is useful if you want an average of the absolute errors without overemphasizing outliers. So let's conclude. Today we learned about classification metrics and regression metrics. I hope you enjoyed watching this video. Please give a subscribe or a like, and leave a comment if you have any questions. Thank you for watching, and I'll see you in the next video.